Hello, everyone, and welcome. My name is Leah Burgo, and I'm the Education and Engagement Director here at Green Building United. We are so excited to have you today for Mimicking Nature to Manage Water on Site. This is going to include a virtual tour of Stroud, but then also a panel presentation with our awesome presenters today. So if you are AIA or ASLA, we do have this approved for a credit hour. I will be sending information to you after the presentation with all of that. Also, this is being recorded, so no need to take vigorous notes. We will be sending the recording to you as well. And 2 points there, as an attendee, you will be able to participate throughout using the chat feature. So if you want to chat with other attendees, with panelists, feel free to use that. You'll also be able to ask questions. So if you look at the bottom of the screen there, or at the top, depending on your setup, there is a Q&A button. And so you click on that and you can ask panelists questions. They may be addressing them throughout the presentation, or they may wait toward the end of their discussion to address that as well. So there'll be a presentation portion, but then also plenty of time to go into questions. Next slide. I want to thank our amazing sponsors, Assa Abloy and CBG South, for sponsoring not just this, but all of our Living Future community activities for 2020. Without your support, we would not be able to make this happen. So thank you so much. And with that, I am going to turn it over to Scott Kelly, our moderator for the day.
Okay, thanks everybody for joining. Welcome to Mimicking Nature to Manage Water on Site, a virtual tour of Stroud. We're going to try to cover a lot today, but we're going to be focused on a couple of specific things as we go through this, and then we're going to get a little more broad at the end and open up for more questions. The agenda is kind of laid out this way. First, we'll do quick introductions of us so you have an idea of who we are. Partially that's so you can mock your presenters. Then we're going to do an 8-minute video. We really want you to get a chance to see the site because it is so beautiful and so meaningful. After that, we're going to jump into a round of conversation around specific topic areas because we wanted to focus a little bit on those. And then we're going to get a little more broad and open it up for just other questions. Okay, so first let's do a couple of introductions. I'm Scott Kelly. I'm a principal from Revision Architecture. My role in this project was charrette facilitation and some lead work at the end and weaving some design stuff through the project. Someone else want to jump in? Dave, you want to go next?
Sure, thanks, Scott. Hello, everyone. I'm Dave Arscott. I'm Executive Director at Stroud Water Research Center. I'm also a freshwater scientist, freshwater ecologist. I've been at the Stroud Center for about 15 years and was our institutional liaison to the design build team during this project, building the Moorhead Environmental Complex at the Stroud Water Research Center. You'll hear more from me later.
Okay, Michelle, Jose, someone else want to jump in?
Thanks, Scott. I'm Michelle Adams from Melior Design, a civil engineer and stormwater engineer for the project. Jose?
Hi, thank you, Michelle. Thank you, everybody. I'm Jose Almiñana, principal with Anthropov & Associates. I'm a landscape and architect by training, and delighted to be with all of you. And with that, carry on. Scott.
Amy, you too. You get to at least introduce yourself.
Hi, I'm Amy Cornelius. I'm a sustainability consultant. I didn't get to be part of the construction group, but I have written about Stroud a lot. And my job here is to watch the chat and the Q&A and queue questions up to the group.
All right, Amy does not give herself enough credit. She's one of the instigators in why this is happening in the first place. And she also was one of the people, or the person that really put together the video that you're going to see in a moment. And Amy, is there anything you want to say about this little video, this 8-minute video?
I wanted to say that this video is designed to orient the audience to the project and to see how beautiful the Stroud Water Research Center really is. What you will see on there is the photos are backed by the site plan. And on the site plan, there's little dots, and the dots are to represent where you're standing when you're looking at the photos. So those will go around the Moorhead complex, behind the Moorhead complex, and then farther afield from the Moorhead complex. But that's, don't get confused by the little dots. That's where you're standing when you're looking at the photos.
Let me just reiterate that no Amy, no webinar. She is behind this happening and gathering all us together. And she's a relentless force. I can testify.
There you go.
Yeah.
Thanks,
And
Jose.
Briefly, there are a couple other people behind the scenes instigating that may be on here as well. Jason Curtis, Lisa Shulock, Michelle Jordan, Chris Lee was in here as well, and a couple others from the Living Future Community Council. So a big thank you to all of them. Okay, now here comes the moment we're all nervous because videos are really hard to do on webinars. So we're going to pray that this works, and we're going to sweat. And I'm going to look at my other presenters here for a thumbs up to make sure that you hear it. Off we go.
Since its founding in 1967, Stroud Water Research Center has focused on one thing: fresh water. Based out of its headquarters in southeast Pennsylvania, its scientists and staff have worked all over the world seeking to advance knowledge and stewardship of freshwater systems through global research, education, and watershed restoration. The Moorhead Environmental Complex expansion to its headquarters was conceived as a place to provide needed space that could showcase the center's research and to demonstrate the research findings through education and hands-on restoration of watersheds. The project's theme, Getting the Water Right, guided the design, placement, and construction of the building and its campus-wide water treatment systems and the daily and long-term operations of the facility. The result is a comprehensive, innovative collection of systems to better manage rainwater, treat wastewater, and utilize roof rainwater for the property that exemplifies best management practices, BMPs, that protect clean water by managing it on-site at the source. A collaborative team of owner, architects, engineers, and landscape architects, many of whom you will meet today, work to integrate the building into the landscape. Stroud Center set project goals focused on reducing groundwater withdrawal, reducing organic and nitrogen pollution from septic wastes, and returning the site to natural forest function by managing stormwater runoff and infiltration. To achieve these goals, the team started with understanding the site's natural resources and current conditions, investigated water uses on campus, and explored alternate solutions for managing stormwater. The project has been successful. The campus buildings increased by 16,000 square feet with a mere 5% increase in water consumption. Testing of the drip irrigated wastewater effluent shows that the quality is better than the local groundwater. The project's green features have been an important educational resource for the Stroud Center's education programs and as a demonstration project for the green building community. All of this while earning LEED Platinum certification along the way. During a typical year, the Stroud Center welcomes busloads of students to the complex to explore freshwater science in the lab and the stream. To meet the distance challenge that COVID presents, the center has launched a Learn at Home virtual learning resource program for teachers, students, and families to explore water-related topics. Hopefully soon, the Moorhead complex will once again team with activity. Before we meet our speakers, we'll take a short tour of the Moorhead complex and the campus to acclimate you and hopefully inspire discussion and questions. A staircase leads us down from the main parking area to brick paths that connect the original buildings to the Moorhead Environmental Complex's main entrance. These porous paths are designed to infiltrate stormwater and channel it to bioretention areas or rain gardens that flourish on either side of the path and along the entire front facade of the complex. Densely planted with native perennials, shrubs, and trees, The rain gardens slow, retain, infiltrate, and, in the case of large storms, drain stormwater through overflow piping under the building and into the rain gardens and fields in back of the building, mimicking the natural flow of stormwater down the hill to the east branch of the White Clay Creek. A few things to note. The greenhouse marries the existing building with the new. This multifunctional greenhouse space houses artificial stream channels for research, an algae farm, and other experimental systems. The greenhouse connects the older building to the complex via an elevated walkway that acts as a bridge between the research and education functions of the campus. The greenhouse also presented a significant design challenge for the collaborative team to minimize impacts on the greenhouse's shading and space needs while enhancing connectivity between the facilities. A metal roof that covers the new building was selected over other roof types in order to reduce contamination of rainwater collected for reuse in the facility. In addition, the rainwater capture system was designed to divert the first 0.1 inch of rainwater away from the water reuse cisterns, as this first flush of rainwater often carries dirt and debris that collects on rooftops in between storm events. This helps to improve water quality that is collected for reuse within the building. The rain chains and sculptures showcase nature-based art and add beauty and a sense of whimsy to the campus. The tour continues on the rear patio. Stroud uses the large wooden barrel to demonstrate rainwater capture to the public. The rain barrel provides a source for garden and grounds watering. Overflow from the rain barrel and other roof areas is collected by two 3,000-gallon cisterns that capture and retain roof runoff for on-demand use in the facility's toilets and can provide the center's water treatment system with water to provide high-quality treated water to its chemistry and other analytical research labs. 100% of the effluent generated at the complex is treated in a constructed wetland wastewater treatment system that is located on the main patio directly outside classrooms, the conference room, and administrative offices. It is, in essence, a working centerpiece garden. Two wetland cells that look like raised water gardens receive wastewater input from the primary treatment and equalization tank and treat it by moving the wastewater multiple times under the surface through the pea gravel medium. The plant roots and microbes filter pollutants, including nitrogen. After treating the water in the wetland system, the filtered water is then pumped uphill to a 2-chamber recirculating sand filtration bed for final polishing, and then to an underground drip irrigation system for infiltration into the soil. This 4-zone drip system runs through a half-acre field containing about 1.5 miles of drip irrigation tubing. 5 observation testing wells are used to monitor groundwater quality, 1 above the field, 2 directly below the field, and 2 below the old and now decommissioned septic drainage fields. The Stroud Center conducts periodic testing on the polished water and has found that the system removes more than 90% of total nitrogen. Basically, the water is cleaner than the groundwater in the field to which it's dispersed. Most of the pictures in this overview were taken during a brief, socially distant visit that reunited the team for the first time since completion of construction. Today we bring them back together to talk about success and failures of the collaborative process, challenges, opportunities, and lessons learned from operating one of the first natural systems in the country, and a celebration of the influence this project has had on others. I would like to welcome to the roundtable Dave Arscott, President and Executive Director of the Stroud Center, Scott Kelly, Principal of Revision Architecture, Michelle Adams, Principal of Meliora Design, and Jose Almañana, Principal of Andropogan Landscape Architecture.
All right. We got that through that with only one glitch. That's pretty good.
Since its founding in
I got to see if I can go one more slide. So bear with me for a moment, please. Okay. Is everybody seeing that image, that aerial? Okay, good. All right. So movies are always tricky, and we still haven't mastered playing them yet. So just for a little more context, this is an aerial that you can see, and it's during construction, so you can see beyond to some of the fencing. You see where the location of the new building is. You can see the existing greenhouse, and that was really a design challenge. Obviously, we can't shade that too much, or we ruin a lot of the experiments. Off to the far left, you see the existing building that's been there for many decades. I can't remember the year of that building. And then you see an existing barn over on the right. And that's essentially where you're parking, walking down the set of stairs towards this new building. There was also a lot of land planning that was comprehensive land planning that was done ahead of time. We're not going to get into all of that. This image just kind of represents a little bit of it, where you can see the pathways down from the former barn to the new center. All of that is really for context. I wanted to put up one other thing, and that is an image of these stream tables, if I'm saying them correctly, Dave. Am I saying, what's the correct terminology for these? You're muted, Dave.
Yeah.
I call these stream tables.
Yeah, the one on the left is maybe a stream table or experimental stream channels or flumes. They're all flowing water.
But this gives you a pretty good idea of some of the stuff that's done inside of that greenhouse.
And we're able to bring stream water into our facility from White Clay Creek and use that for experimental purposes. So that's quite critical for our research program here at the center.
Very briefly, this is what I'd consider the south facade. I'm an architect. A couple of the people on this presentation are also architects, and you look at this building and the first thing most architects see is not the water. They see the photovoltaics on the roof. And that's just tends to be our perspective. But we really have to remember that the key to projects like this is the site is the place that supports that building. It's not that the building is there because of the site. So it's a little bit of a reversal. Let's go on to one other image. This is the north side, really where the entrance is with the greenhouse. All of that is for context. Briefly, the team did put together these diagrams, and any one of you are welcome to jump in and explain this, because you'll probably do a better job than I will. But this is the diagram that explains how the stormwater flows through the site, coming from, let's say, the parking lot on the back side of this building, working its way around, going through some filtration methods, and then back to the level spreader on the left. You see rain coming from the roof, going through the rain barrel, going through the runnels on the site, which are beautifully crafted. That's one of my favorite details, Jose.
Scott,
yes.
Hey, Scott, Michelle has a point that we should point out where the creek is. Where is the stream?
Behind us.
Yes. But
So
I think in that one of those overheads, you probably had a good picture of it.
Let me go off script here a little bit, and I'll go back to that overhead. So if you see where most of these pictures are taken, they're here, but the White Clay Creek is a few hundred feet off to the southish. And that's, if you can see where my cursor is moving, that's the location of the creek.
Hey, Scott, maybe
Please.
I could go off script and jump in here too, because this is a great slide to explain. So the Stroud Center has been at this location for our entire existence. We started in 1967 as a field station at the Academy of Natural Sciences of Philadelphia. We're now our own 501c3 nonprofit. But the building closest to the stream at the bottom left corner of your slide is an old stone barn that's closest to the road. And that was renovated in '67 to be our first research building. And since then, our expansion projects have moved upwards in this picture, not exactly north here, but to expand our square footage to a total of about 55,000 square feet indoor space. And you'll see we're really close to White Clay Creek. This is a federally designated wild and scenic river corridor. And we've been studying that stream for our entire existence, 52 years now. So this is really critical to who we are and what we do. And you know, we wouldn't normally be building a large building like this so close to the creek to get the water right. But the new building has about 10% of its footprint in the FEMA floodplain. So I just want to note that now, because that's one of the challenges I think we'll talk about later on.
There was a lot of discussion during the charrettes about the placement of that building and how we bring it back and still accomplish the mission of Stroud. Okay, let me jump a few slides ahead. That was a little bit on the rainwater, the stormwater. And here's a little bit on the black water. What we're doing is we're taking all the wastewater from the building, essentially putting into a treatment tank. It's getting its first level of treatment, pumping it uphill into these wetland cells. There's 2 of them. And you're going to see some photos, and we're going to have some more discussion about them later. Goes through some filtration. And it's getting, essentially, when it's clean, pumped way up to a sand filter and in a disbursement field. One of the things that I note that Amy said in the presentation is the water that's going back to the aquifer is cleaner than the water of the aquifer, which to me is exactly what we were trying to do.
Yeah, and I'll just add that we're in locale in Southeast Pennsylvania that's had farming in the landscape since early colonization period. So we do have a legacy of agricultural influences on our groundwater quality, particularly the nitrogen content is a little bit high. Still drinkable, still potable for nitrogen, but the treatment process, as Amy mentioned, removes about 90% of the total nitrogen, and that results in a concentration that's lower than what we find in the groundwater monitoring wells nearby that drip field.
Okay, moving on. We're going to now have some conversation around these topic areas: the success and failures of the collaborative team, the challenges and opportunities of operating a natural system. Obviously, we're trying to mimic nature, and that can be very hard to get that right. Some lessons learned from the project, and we're going to celebrate some of the influences of the project. And we'll stay here, and then we'll probably open up to some general questions after that. I do think we really need to start really with you, Dave, because you are the man of the hour, and we need to have some very quick conversation on how we should define getting the water right. So from your point of perspective, what does it mean getting the water right?
Yeah, well, first and foremost, as I've already shared, we're a freshwater research organization. We educate the public and we work with landowners to consider best management practices that protect water quality in streams, rivers, wetlands, and entire watersheds. We have a long history at our current location in Southeast Pennsylvania in Chester County. And as mentioned, we're on the banks of wild and scenic river, White Clay Creek. In addition, we're clearly out in the rural part of the countryside. And so we're not serviced by municipal water utilities, drinking water or wastewater. So we depend on the groundwater for drinking. We had, prior to the project, we had a wastewater treatment system, which was a traditional septic tank and drain field, and that was nearing the end of its life. So that needed to be addressed. So this question, how do we define getting the water right, which ended up being sort of our theme tagline for this project. The Stroud Center and our staff, employees, and board were intent on thinking through all aspects of how water from raindrops to groundwater and well water move through our campus, in and out of our buildings. We wanted to address stormwater issues to reduce runoff and improve infiltration, to address consumption, water consumption in our building. How can we minimize use? And to address the wastewater treatment system, as mentioned, we needed to upgrade. We wanted to not just improve the efficiencies and the treatment, but we also wanted to improve our campus to demonstrate these approaches to how we mitigate, minimize the built environment. And ultimately, we wanted this project to lead by example. So I think there's others involved with the charrette that can add a perspective as well on getting the water right.
Michelle, from your perspective, from the civil engineering perspective, how do you define?
Sure. What I recall, Scott, is early in the design conversations, we looked at how the site would have functioned when it rained, when it had been a natural forest before anything was built, and how it functioned as it was when we started the design. And even being out in the countryside, there's an impact from the runoff, from the on-site wastewater, et cetera. So that quantifying how our system, existing conditions were functioning compared to nature gave us a starting point to inform the design. And set metrics of performance, or at least goals. I don't know, Jose, do you want to add to that?
Well, just from some of the conversations we had them and some of the conversations in preparation for this webinar, we brought up some ideas about water that I think is important for most of you in the audience to take home. First and foremost, the idea that there's only one water in nature. That anything that divides water in nature is a human construct and interpretation of what happens there. So it's part of a larger system that we are inserting ourselves into it. That's the idea of getting the water right is really understanding that is used in many ways as a resource by many aspects of the living systems that are in any given site, including human beings. So for instance, the groundwater that is needed to be used for experimentation or Stroud will be water that needs to be processed and use reverse osmosis, if I'm not mistaken, to actually create clean conditions of water. And that led to the thinking of, well, what if we were to collect rainwater? Wouldn't that water be better than the water that is somewhat hard from the calcium deposits in this calcium derived landscape? You know, it's a limestone landscape in many places in this area. So that was part of thinking about water in that regard. And then when we look at water, we also think about water from the perspective of blue water and green water. Blue water being the water that you can see, the rivers, the estuaries, the oceans, the springs, the rainwater, ice. And the green water, which is that water that is actually in the soil, that becomes part of the plant tissue, and that actually reconnects with the atmosphere through evapotranspiration. And that's an incredibly important aspect of the water and the soil connection and the plants, where it's a system that we try to actually identify as a significant component of the entire project. And hence the idea of really understanding how that green water becomes part of a critical part of the hydrologic cycle. We're reconnecting water in ways that is not possible because of the development of the land that we tend to do with all our projects.
There's another part of this that we're not going to go into, but from like the architecture perspective, water has an effect on our carbon footprint. We use a lot of materials to move it, and we use a lot of energy to clean it and get it to where it needs to be. For today, we're going to kind of leave that to the side. From here, I'd like to talk a little bit about some of the successes and failures of the collaborative team. We facilitated and used a very different process, considering this was 10 years ago. And through charrette facilitation, we got to work with other scientists and designers from the very onset of the project, side by side. And that really changed the trajectory of the project. This diagram kind of shows a little bit about our team. And there were some successes and failures in using this process. And Dave, maybe I can call on you to talk a little bit about how this affected your staff or innovation or board or culture of the project.
Yeah, certainly. the design charrette really, I think, helped build internal consensus and community agreement of what we envisioned for this project, and is where the focus on water was born out of. It involved many of our board members and staff members. It was facilitated by the folks participating here today and a few others. I wouldn't necessarily point to any failures around the project, but maybe more like challenges or lessons learned. Certainly, I think in hindsight, we can recognize that some steps of the construction project would have gone a little bit differently, maybe had our general contractor been involved at this early stage in the planning process. But I think, from the Stroud perspective, it was effectively communicated to the design team the importance of the greenhouse, to our research business. And I think, that's where the idea of an addition connected to the greenhouse came out of. I think it was also noted that we've been here since 1967, but the farm that was adapted comes, I think 1740 is the old log cabin on our property here, and the barn structure is 1807 or so. So that's well before thinking through stormwater management, stormwater issues, and impact on the creek nearby. And we recognized that we needed to address stormwater in a big way. We're on a hillside that sheds water right down to White Clay Creek. So, that was an important component that was communicated in the design charrette as well.
Jose, Michelle, anything you want to add?
Well, a couple of members on the audience have talked about the siding of the building. If you look at the entire development footprint of the site in terms of the collection of buildings that exist there, proximity to the creek was important from the perspective of a resource. The basic land available tend to be flatter, closer to the creek, so it was easier to develop. I'd venture to suggest that this was one of the reasons why the development happened that way. It happened in successive stages, so there were additions to buildings, very much like you see in old farmhouses, with the additions being on either side of the house, most likely in one side. And then eventually we had to come up with this location for this building. And orientation, solar axis, understanding gravity, and the movement of water through the site, led us to where we are, which interestingly enough, the building became a dam in terms of the movement of water from the uplands to the receiving waters and the east branch of the Clay Creek. So lots of things had to be done to manage the water coming from uphill, to find places for it to be infiltrated, and to find places for it to overflow and find its way down towards the creek. And by reducing the amount of runoff generated by the new development, we were able to minimize the necessary infrastructure to keep the building dry, basically, and be able to actually construct this. To the extent possible, the constructed wetlands use certain amount of gravity to minimize the use of energy to move water across. But one thing that I want to point out for all of you to know is that this project is kind of like a little project that could. It started by being a project that needed to pay attention to the long-term operation budget for the project, because as you know, many grants and many contributions to projects are for bricks and mortar and not necessarily for the operation. So very early on, one of the drivers for the project from the client side was make sure you design a building and a site that we don't have to spend a lot of time, a lot of money maintaining it. hence the idea of an integrative design process, hence the idea to look at every little bit of energy used for the site, hence the idea to actually generate energy on the site. And little by little, the project evolved to the point where, you know, the idea of applying for certification by LEED, from LEED became a reality. And lo and behold, the project that started just being, you know, a well-designed and well-conceived project ended up getting the platinum certification. So I think that it's part of the fortuitous evolution of the project in that regard, but I'm a firm believer that you are always in control of your destiny, and you put yourself in the right place for this to happen, and you bring in, you interact with people in a way that make things better, and this was, you know, extraordinary in that regard.
This is a couple images that show you kind of when we all came together in the very beginning to flesh all this out, to go through all the details, to have the interaction between the design team and the scientists. And people always talk about, you know, having the right experts in the room. Everyone on the design team realized one thing: the design team weren't the experts. It was the water scientists that we were in the room with that were the experts, and we all had to listen very carefully to them. Sometimes we needed to be told 2 or 3 times until it finally stuck in, but it did. And that's part of what made it so successful. Michelle?
Yeah, thank you, Scott. Could I just add, I wanted to reinforce Dave's point, because Stroud didn't just have client representatives engaged, their staff were engaged, so that the people who would live in this building were part of the design and knew what they had when we all went away as the designers. And also to reinforce Dave's point that if we had had more involvement from the contractors during the design process, I think that would have been helpful, because building it is so important.
Yeah. Mason was brought on a little later. Dave?
I'll add to emphasize what Jose mentioned as well, that the Stroud Center didn't enter into this project with the idea that we're pursuing LEED Platinum certification. This evolved as sort of incremental decisions were made to improve conditions at the Stroud Center. But we've also had some interesting older infrastructure here that I think is a little bit on the forefront of building technologies. So we had geothermal wells previously installed in the mid-90s, and we had a composting toilet system in our old building, also, I believe, from the early 90s. So we did have some experience with those systems and their challenges. Nevertheless, we added those components to the new building as well. A new composting toilet that services our education classroom. We added more geothermal wells to our well field, and ultimately have really improved water efficiencies and energy use, in addition to those goals for getting the water right at the Stroud Center.
In closing on this slide, one of the lessons I think we all learned on this one is how helpful it is to have a construction manager around the table from the very beginning of the project, and to be able to give us all guidance on costs. I'm working on a project now from Muhlenberg College, and we're trying to figure out exactly where the building should go so we could save, you know, $150,000 in shoring costs. We wouldn't know that as designers, but when you bring in somebody who's got the qualifications from the very beginning, I think projects tend to be more successful and more cost effective. Okay, moving on. We should talk
Scott,
a little bit.
just first about the siting of the building. Brad is asking if there could have been another spot to put this building to prevent pumping uphill of the effluent, and what that did to overall energy use and LEED certification. But maybe talking about the constraints of the site too, not just
Michelle, do you want to take that one? Mr. Muted.
There we go. Sorry about that. Sure. Well, the existing building had the on-site septic system that already had to be pumped, and we were connecting to the existing building. So we were in a situation that in order to stay down there with the existing building, we would have to pump up to the better soils to dispose of the wastewater. I don't have any information. I don't know if you do, Dave, on the energy associated with that.
I have some anecdotal, but fundamentally we're in a situation where we're not going to be able to infiltrate between this building and White Clay Creek. It's not feasible. So we already know that we're
allow it.
Right. So we know we're already going to be pumping uphill. I know that from other net zero energy projects we've designed, I know that pump energy can be significant. So you just have to be very, to be careful. Even the size of the actual pipe has resistance in it and will influence the size of the pump. The last part of that question, Amy, had to do something to do with lead too. Could you repeat that?
He's wondering if the overall energy use had any impact on the lead certification of the project.
Yeah,
maybe.
The pump energy to move all this effluent uphill isn't huge. It still is on the chart, but it might be 3% of the entire energy of the project, maybe less. So not big, but still notable, because ultimately you don't want to have it 3%. So if I remember the way the energy model was done, we did include the pump energy in there, and it did increase, essentially 1 lead point. But it was still the right thing to do to get the water right. Hopefully I answered that question.
And I'll just add that, the owners probably drove the choice of the location. And, that's related to what Michelle brought up, that we wanted a single system that was fairly well connected. We wanted our employees to more or less be housed in a connected building because so much of what we do is collaborative, challenging now during COVID, but we thrive on working with each other and having that connection. And, a substantial portion of our work in education brings visitors out to the center. And although we have teaching spaces, we also offer tours, and tours that focus on the research we do, tours that focus on how the building functions as a green building. So the proximity of all of that together is really a bonus and something that we wanted to keep intact.
Okay, let's go on.
If you can stay on that slide for just 1 second, because I think it's
sure.
important, is that we did have not only buildings in place, we also had an extensive road infrastructure with areas for parking already existing, generating runoff and doing all those things that we needed to deal with. But in order for this project to be successful, it has to fulfill its educational mission. And part of that educational mission is to be able to bring in students here that usually get brought in a bus, and there are dozens of them at a time, and not all of them are capable to negotiate stairs. And you have this brown squiggly line in the drawing that you can see right now that is basically what allows for anybody with disabilities to actually come and enter this building. And that was an important driver in the layout and the grading and the movement of water throughout the site. And it also brings in people in contact with water in a way that is very experiential and very significant and part of the educational experience of coming to the site.
Okay, moving on to some lessons learned. I think one of the lessons that we've all talked about is something that Stroud had to manage and deal with over time. And that is, Dave, you had to do a lot to be able to satisfy regulations on this project with water. Can you tell us a little bit about that?
Yeah,
maybe...
so we have our acreage in an easement, conservation easement, which had an impervious surface maximum percent of 5%. And we knew going into the project that with the extra roof and sidewalks, we would exceed that 5%. So number one, we needed to purchase some more land contiguous with our existing campus. So we had that obstacle to move through. Certainly being next to a wild and scenic corridor and White Clay Creek is also a exceptional value stream based on Pennsylvania DEP's standards. So there is the need to show that you have minimal impact on water quality through the anti-degradation laws. So re-permitting a wastewater system this close to the stream was also a concern. And with the design team's suggestion and our discussions settling on the wetland wastewater treatment system certainly presented permitting challenge because it's a non-standard system, or at least was at that time. Not too many of those permitted in the state of Pennsylvania. So we had to navigate those obstacles as well. Ultimately, we received the permit and we received a grant from Pennsylvania Department of Environmental Protection to help offset some of the construction costs for the wetland wastewater treatment, as well as the stormwater management system, the rain gardens. There were other challenges, but that's enough for me for now.
Michelle, do you have any challenges you want to add?
I would say that the grading and the topography, because to make the site work for all the reasons Jose was talking about in terms of accessibility, as well as to make the drainage and the stormwater work, it was very careful landscape grading. So again, the construction of the landscape and the earthwork were a challenge. And I think in the end done well, but definitely something that has to be carefully managed during construction for a project to perform.
I've heard you and Jose talk about doing grading with a spoon. And you need to be literally that detailed to just get it perfect. Another conversation we've all had is what's being taught in schools versus what we apply on a project like this. Should we have any discussion about the differences of what's being taught in the academic environment versus what might be needed?
Well, I won't address that per se, but your grading with the spoon comment, just reminded me how critical millimeters of elevation are, particularly with the rain gardens and the stormwater management plan. So, towards the end of construction and post-construction for the first couple years, we're a bunch of freshwater scientists. We go out in the rainstorm anyway, but we're walking all around campus looking at the overland flow tracks and seeing what small modifications need to be made to direct the water into the management system. So that was, I think, a big challenge sort of post-construction for us to get that water right as designed. Some of it is just so subtle, it's difficult to catch, I'm sure, from a field practitioner in the construction industry. I'm sure that's a huge challenge.
So for the people who are joining this webinar, one thing you've heard us say before, and you just heard it said now, it is so important for us all to go outside during a rain event to have some understanding. And that's a takeaway that all of you should have. The next time it rains, have your rain gear ready and just go walk around your neighborhood or wherever you are and watch the flow of water. And so quickly you'll see what's working and also what's not. There's another issue that we all dealt with in designing projects like this, and that is we designed with the current knowledge of the time. And climate change is changing everything so quickly. And I don't really know how to address it, but, does our current design now get influenced by climate change and what we might perceive is going to happen in the next 10 or 20 years? How does that affect, Michelle and Jose, your work?
Yeah, and you had also asked, Scott, about what we're taught in schools versus practice. And I would take it a step further and say it's not just what's taught in schools, but our regulations about water and stormwater have a hard time keeping up with the times and keeping up with the changing climate. For the engineers who might be listening, we're still using engineering calculation tools that were developed and assumptions that were developed before we had computers, before we had better data. And a lot of those things get built into codes. And so we still have to live with them. I should add, with this project and with many projects, you have to go through certain analyses to get your permits, and that's a good thing. But we also look at actual real rainfall data from storms. And in this case, we use data from the Philadelphia airport, and we look at 15-minute rainfall segments for the worst storms, the hurricanes, and we look at the worst intense storms, those microbursts we're getting more of now. And when you run those actual storms through your system to see what it will happen, on the computer, that's a good tool to use regardless of regulations to know if your system's going to function once it's built or function close to what you're hoping for. So I think there's a bit of a burden on the design professionals to look forward and not just depend on regulations, but look at what's really happening and bring that into their design consideration.
Well, I would add the almost 10-year perspective of watching the system function. We've had some really whopper rain events, particularly this year, even beginning of August here in Southeast Pennsylvania. The system performed as well as can be expected. There have been no blowouts of the rain gardens, no massive erosion that has changed flow paths or required severe, extreme maintenance or fixes. And that's a testament to the design and the design capacity as well. We didn't go over in a heck of a lot of detail the stormwater system, but I believe there's 12 or 14 rain gardens that are designed in 2 to 4 clusters that are connected with overflow structures or drop structures to manage to a level of spreader. There's roof rainwater capture, and there's permeable paving systems. In addition, in the upper parking lot, there's a large infiltration trench beneath the parking lot. And all those systems function pretty well together 10 years out with some really extreme rain events. So I feel that that's a big success on the project.
Jose, anything to add?
And the landscaping from Jose's group has stood up really well. Beautiful gardens.
Well, one of the things that is always a little bit of a struggle as we practice and anticipating change, because we know change is occurring, but we don't know how much it's going to be. So the way nature is resilient, is adapting to change. It has had time on its side to be able to sustain disturbance and evolve after that disturbance. Right now, we don't have that because the changes are happening too quickly. So when I was referring to this idea of the one water and the green water and the blue water, is that the soil and plants system is so critical for this to be able to actually adapt to changes in the future, because the more robust and diverse environment that you can create in terms of life is going to have the greatest amount of resiliency. So in the process, we were fortunate that we had a site that we could actually incorporate a lot of, we had first and foremost a distributed system where we were actually able to capture water at the place it was generated and manage it pretty close to the source. That is not always the case. but with the idea of getting the water right, that was a given. You know, that was a very significant commitment from the client side and then from the team to actually make sure that that was a mantra that we didn't lose sight of. So what is going to happen in the future, I'm not quite sure, but I can guarantee you that the trees that were planted 10 years ago that were maybe evapotranspirating 15 gallons of water a week are now probably evapotranspirating 45 gallons of water a week. And I'm making up these numbers, but it's a significant more robust system than the one we started with. So you're building into that, into the project, that component of life and evolution that you don't have always the opportunity to do. But once you're presented with the opportunity, you have to do that as a second nature, right? The level spreader that Michelle referred to, which is right to the right side on this photograph, lower right-hand corner, is the last line of defense of the site. Is basically where all the pipes come together and they actually spread evenly across the front, avoiding concentration and actually going down and reintroducing that water that has been captured and managed back into the creek. So all those systems, I think, that have to be built in as belts and suspenders, and time will tell. Time will tell if what we did is right, if the management that we've been using with these living systems makes sense, if this is hindering their evolution or is actually aiding their evolution. Observation and adaptive management has to be incorporated in a system like this. There's a number of questions from some of you about, the performance of the constructed wetlands. Nothing is forever, and at some points things need to be changed. But there's eons of years of evolution of natural systems working together that we cannot just simply dismiss. Deep roots, diverse soil biota, incorporation of nutrients into the soil, making it plant tissue, making it available as food for other organisms. That is absolutely key. That is the engine that keeps us alive. And that's the thing that I think makes this project successful in some ways.
Okay, thank you. One of the other successes that we're not really going to drill down to in any detail was LEED. And nobody ever puts up a LEED scorecard and captures the attention of the audience. It just doesn't happen. So we didn't do that. But there is a little point that we should touch base on, and that is through the LEED process, knowing that it's hard for any nonprofit organization to raise funds for operational costs. We were able to demonstrate to the board and the staff what those energy savings might be and make sure that certain items stayed inside of this project. And that helps reduce the operational cost of Stroud. And that was one of the ways that we were able to contribute to get to the LEED Platinum certification. Does anybody want to add anything about LEED or that at all?
Well, one thing about LEED that is always, I find is fascinating, is that it's a set of constructs and values that are external to every individual. So it's a reference point with some performance standards and some criteria that you aim to achieve. So it helps everybody focus into that aspect of the development of a project, the design of a project, implementation of a project. And it's always a way to check and make sure that you're doing this the right way and being efficient about it and checking it against budgets and so forth. So I find it incredibly useful. But mind you, I'd like to say this again because I think it's an important aspect of this project. This was not something considered from the beginning. The take home is that an integrated design process, if done properly, will actually make the achievement of certification, sustainability certifications, a lot easier than not.
Yeah, and I also would say without doing these metrics, you really don't know where you're going to end up. And right, and I see so many projects say, oh, we're going to design to the LEED standard. And then we get hired a lot to go prove that the team did or didn't make it from an institution. And I would say more than 9 times out of 10, if you didn't actually do the math, you missed. You probably didn't even make certification. And it's unfortunate, but it is one benefit of having a rating system at all. But nevertheless, getting the water right is what drove this project. LEED was an additional outcome of it.
Right. However, let me just say something else about this, because this is an important aspect of LEED in terms of what it also provides the client with. And it provides the client with the assurance that the building the systems have been built and commissioned the way they have been actually designed and implemented. And that is very important. Where I think LEED falls short is when it comes to the site and the idea of site commissioning. Because if we're going to have a site like this one, for instance, where we want to make it perform certain ways so we can get the water right, I think that it is just as important to commission the site as well as the building. The difference with the site, and I'll say this again because I think it's important to take home, is that it's always going to change because it is alive. A pump is not alive. A pipe is not alive. A PV panel is not alive. Energy is not alive. It's not going to change significantly. Everything you build outside that has some kind of interaction with the living systems is going to have life and evolution on its side. And that has to be something incorporated into our thinking.
Well, LEED has introduced a lot of that commissioning as a best management practice, and now we do it all over. It's had it grow through building systems. Now it's enclosure systems on the architecture side. Hopefully they integrate site commissioning at some point. And to reiterate that point, the difference to the site commissioning is it is an ongoing process. It's year after year testing and making sure that your site is performing the way it is, whether it's soil health or whether it's tree health or stormwater management. All of that should be checked on a regular basis. Okay, let's go on and talk a little bit about some of the influence of this project. We've already touched on some, but this project did have some strong influences, I think, on policy and Dave on Stroud's ability to help others through this regulatory process. Can you tell us a little bit about that?
Well, maybe not so much through the regulatory process, but certainly we are open for sharing and teaching others about what we've built here and what the process was at the time that we built it almost 10 years ago. So we've had many tours and interested parties coming in that are considering either a green building or a LEED certified building, wanting to see aspects of the facility. I think quite a bit of interest has focused on the stormwater management aspects of what we have here. Yeah, so, you know, I understand there were some on the team that are also quite heavily involved in U.S. Green Building Council and LEED certification, and there's some influence of the water aspects of this project on future iterations of LEED certification that maybe others can talk about. Scott or
Shall I throw something in?
Well, LEED has certainly evolved since this project. Were you going to say something, Amy?
I was going to say there is a question here from one of the attendees asking are the drawings and information about the project available, given it's a research place for people to come and look at and see? Trying to go back to it. And I don't know if I don't think so. Dave, is that right?
Well, I don't have like the construction documents posted for public download, but certainly if people want to contact me, I'm happy to share details or at least send you to the design team to ferret out details if we don't have them. You know, we do have a full set of plans. There's a website that I think got posted in the chat. That's our Stroud Center / facilities website. And in there you can go to the Moorhead Environmental Complex. We have education kiosks around campus, and those are all posted as PDF downloads. We have a small booklet that I believe is also posted there that we've put out for public consumption on the Moorhead Environmental Complex that, you know, has some of those site plans, etc.
Okay, thank you.
One of my favorite things to do is crawl around your building and just look and be like, what's that? What's that? What's that doing? And the site as well. And so I'd encourage everybody, when the time is appropriate, to go out to see this center. Stroud is an amazing place. It's an amazing, beautiful place to visit. It's one of my favorite things to get out of the urban environment I live in. Go ahead,
I should add, Scott, that, you know, we're not necessarily open to the public, but we do have public events which open us up. But particularly during COVID, we try to minimize visitors on campus. And during our normal operations, we have so many school groups through that we also try to restrict visitors just for the safety on our campus. But you can contact us and find a public open house or schedule a tour. That's no problem.
Yeah. Okay, in kind of closing this segment here, one of the clear messages that I think we should convey is how this project changed all of the designers' approach to water, land, and soil. And as we started on a journey back here with Stroud, we've kind of ended it in the what we would tag as a living future and a living future community, where we look at all of these issues, including stuff related inside of the building. So perhaps you all want to add a little something on that as well. Education and listening as an architect is such an important skill, and not just doing something in your own studio in a bubble, but doing it collaboratively with others. And to me, that's one of the gifts that Stroud gave this design team, that gave me, was honing skills and understanding how important that listening is, listening really of your client's needs and desires, and then finding a way to fulfill them. Jose, Michelle, Amy, anybody want to add anything? Or we can kind of open it up for general questions too.
I just think anything we as designers can do to help the public, to help our clients, to understand the connectivity of systems. And sustainability is such a tired word, but to understand the importance of thinking of how we build and design and live and our impacts. Anything the designers can do, every little step helps when you can spread the message a little bit, because people then take that forward.
Jose, Dave, Amy?
Did Dave talk about drinking the water? Did we talk about that during this? I may have missed it when I was looking at questions, but part of getting the water right was being able to drink from the sky, say. And I'm wondering if we were able to do that.
Yeah, certainly on successes and challenges and lessons learned, there's plenty of fodder there. So part of getting the water right was considering reuse of rainwater. I had already mentioned we're drinking our groundwater, and we are basically a public utility for our employees, and have the requirement to test our water and submit to the Department of Health the potability standards. We were interested in capturing that water and potentially using it for drinking water. And if not drinking water, certainly to use that water to send to our analytical chemistry labs. We have some additional water treatment to produce chemistry lab grade water that's very pure, ultra pure. And thinking about that treatment process for groundwater versus rainwater, the thinking was rainwater is a little bit more pure, fewer dissolved materials in there, and should be more efficient to clean with less reject water. That's something that's a success of the project, that rainwater system was plumbed in and can feed to our analytical chemistry lab. We also, as I mentioned, wanted to drink that water, and that also drove us to consider this first flush diverter. I think I saw in the chat or Q&A about that first flush diverter. So that takes the first 1/10 of an inch of roof water and diverts it away from the cisterns that are buried in the ground, so that you can have an even more clean water in your cistern. There were some mid-project changes to that system that did ultimately impact the water quality in the cistern. Certainly still would be potable, but it went from a fiberglass tank to a concrete tank, and we did not line the concrete tank. There were many different reasons for that we can go into, but ultimately an unlined concrete tank does have some leachate for standing water, will dissolve some of the calcium carbonate in there and increase your total dissolved solids. So it starts to look a little more and more like groundwater the longer that water sits in your concrete tank. Certainly not toxic for consumption, but another aspect of cleaning the water for the analytical chemistry. And then the other, we don't drink that water. We don't have it certified or tested for potability, primarily because the regulatory environment would require that we treat that as another source system and have to do additional testing. So the finances don't really make sense for us. We're already spending the facilities money testing our drinking water from our well. We'd essentially be doubling that budget to also be testing the roof water system for potability.
So on that vein, Dave and Jose and Michelle, I wonder what regulatory changes we would need to make ourselves go beyond getting the water right to actually having real circularity from the sky, and what we would need to do to push the envelope even further. Thoughts?
Really, I would say number one thing would be to actually price the cost of water right. If we were paying what we should be paying for water, water will have a completely different value. The one reason why we're talking about a stormwater here is because of Clean Water Act that happened, I don't know, 40 some years ago, right? That added value to water by the famous swimmable and fishable waters of the country, right? Those string of a dozen words or so. So if we were to understand the nexus between water and energy correctly, and we were able to price it correctly, the value of water would be different, and we would be able to actually make these numbers work. It's also a question of supply and demand. You know, in places where water is scarce, you drink it from the sky. It happens all over the world. Ask somebody in India if they have to actually test the water that they drink every day. It just doesn't happen that way, right? So I think that is a significant socioeconomic and political conundrum that you have to address. And if that happens, I think that we would be doing, you know, the planet and all of us a big favor.
If you price the water the same way that Bermuda prices the water, everybody would capture it off the roof, put it in their basement, and drink directly from it. And that's what they do.
And mind you, in Bermuda, they collect water from roofs that are made out of asbestos. So that sink a little bit for everybody.
Yeah.
But anyway, I think that, you know, I do think that, you know, these are projects at the forefront, trying to do things different, trying to be able to demonstrate that there are other aspects of the design thinking that should be explored. The fact that now we have proof that a decentralized system for wastewater treatment is more efficient than the typical, sediment tank and pumping, effluent into the soil. It works better. It has all kinds of benefits associated with it. We need to just simply expand our spreadsheet and understand what the cost of everything that we do are. And I think that will change the perspective on all this, seemingly inexpensive and given systems that we take for granted.
Michelle?
Scott, real quickly, if I could just add one thought about awareness, if we could ask our participants, when they fill up their water bottle today after this, do they know where that water coming out of the faucet or the water bottle in their fridge came from? Do they know what stream, what well, is it spring? Where did the water start? And when they flush, where does it go? Like, just even thinking about where it comes from and where it goes is where we start. So I'll stop there.
Well, I'll just add to, it's to Jose's point about pricing water, what it costs to get it and treat it. It's not really in the business model to fluctuate the cost or the price as you drink your water. But certainly the utilities and the drinking water providers out there have a range of water quality that they deal with, particularly if they're taking their water from rooftops or streams, rivers, and reservoirs. Sometimes after rains, that water's a little more dirty and poor water quality and costs a little more to clean it, and other water sources cost less to clean it. So how dirty was the water that you just drank? Even if it's the same faucet of what you drank yesterday, it might have cost more or less to treat that, even in your same system. Yeah. So, we all have to do our part to protect our most precious resource on Earth.
Yeah. All right, we have about 8 minutes left. Are there any other general questions that people want us to try to answer?
There are a lot of questions about the maintenance and long-term maintenance, life of the system, and how maintenance got started up, like what the learning curve was. And I don't know, Dave, that's huge for 7 minutes, but I wonder if you could talk to that a little bit.
Yeah, certainly. I would chalk that up as one of the lessons learned for everyone out there, that there can't be enough education for your facilities and maintenance team from the very beginning of the project with this level of complexity. We haven't gone into the lighting controls and the solar panels and the geothermal and balancing and there's been a focus on the wetland waste treatment and the stormwater, but absolutely the learning curve can be incredibly steep to operate, maintain these systems. I think we've risen to the challenge here at the Stroud Center and kind of found our marching orders, but there are challenges with we're wastewater treatment operators, basically here at the Stroud Center. So there's always trying to ferret out what might need tweaking, or which pump is in need of replacement or maintenance, or is the wetland waste treatment system perking and flowing the way it should be. Those are all things we have to pay attention to. There was one question about the vegetation in the wetland cell, and yes, that has to be harvested. The standing dead needs to be taken down every year. You do want to keep those gravels, as loose as possible. So there's the porous paving for all of our walkways is another maintenance burden to keep the weed growth from growing up in the cracks between the bricks. And slowing infiltration of water to the perk bed beneath the walkway. So, you know, we could go on probably ad nauseum with those little challenges, but collectively those little challenges add up to requiring a lot from your facilities and maintenance team. So make sure you go into a project with that team eyes wide open as you can.
They should be there around the charrette table so they learn what we're doing and buy into the process.
Mm-hmm.
All right, Amy, what else are you going to throw at us?
There was another question here that on the heels of this answer from Dave is about the performance of the constructed wetlands in the winter months. And while in the winter months, there's indeed little biological activity above the ground, there is still quite a bit of biological activity below, you know, in the water, I should say, not above the water, but below the water. The bulk of the cleaning or the cleaning of the water and the uptake of nutrients from that wastewater occurs in the root zone of the wetland systems. And that remains as long as the temperature is such that it doesn't freeze. And I don't think it freezes because water is coming out of the building fairly warm. And also there is certain amount of organic matter in the, you know, the vegetated portions of the plants that it stays on top of the constructed wetlands that creates a cushion and isolates that from cold temperatures. So there is a lot of energy still occurring on that on that layer, and while it may decrease the amount of biological activity, it is designed so there is enough to manage the flow generated.
Yeah, and I would add that, you know, we collect data, take samples, water quality samples throughout that system before treatment. It's basically septic water. And midway in treatment and the finished product. And we do that regularly throughout the year. And we can see that some of those seasonal patterns that reflect temperature and above ground biomass activity. So yes, you get some enhanced treatment in the growing season, but really most of the treatment is being done by the microbes in that soil gravel matrix for the wetland cell, as well as there's an aeration drip tower that's part of that. So there's two main treatment systems. So you have aerobic bacteria and anaerobic bacteria that work together to remove the nitrogen and process some of the carbon and other constituents. And they function quite well. We haven't had freezing problems in those systems, but I would imagine if you're trying to build this system further north, that is a key limitation to a system like that.
Mm.
You make them deeper from the ones that I've seen a little further north. So we are at closing here. We're going to wrap up for time, but I think before or as we do that, we probably do need to acknowledge Musco Martin, who is not with us today, no longer with us, but was critical to the success of this project. And Jose, do you want to add anything about Musco?
Well, I think that the old adage of, you know, great projects have great clients, and this is certainly one of them. Great projects have great leaders, and Musco was the leader for this project and the design team. And having this presentation without mentioning him will be not fair and wrong. So we thank him for what we learned from him, and we miss him. So there you have it.
Okay, thank you, everybody. We're going to go back to Leah for a moment.
Okay, thank you. Thank you, everyone, for sticking with us, for all the really great questions. Thank you to all of our amazing presenters. You did a great job, and I imagine this could have gone on for a couple more hours at least. It sounds like there were lots of really good questions. Thank you again to our sponsors for making this happen. And then the final slide is just a reminder that this recording will be added to our webinar library, so you can always access it there, but I'll also be sharing the direct link for you. I'll be following up about CEUs, so if you are in need of those Lacey's credit or the AIA, I will email you about that. And if you have any questions, you'll also be able to ask speakers directly because I will be copying them on that thank you email. So with that, thank you everyone for joining us, and we will see you again at the next virtual event.
Okay, thank you, everybody.
Thank you, everybody. Bye-bye.